Welcome to part 3 video lecture on topic de Broglie equation. Nature of light. According to quantum theory of light, refer to the particle nature of light. Classical mechanics refer to the wave nature of particle. Light is said to be possessed to the dual nature. It behaves like wave in one equation but as particle in another equation. Though according to Einstein, light behaves like a dual nature, wave nature and particle nature. When is it a light, wave and when is it a particle? Whether light display, wave or particle nature depends on the object it is interacting with and also on the experiment setup to observe it. If an experiment is set up, observe that wave nature such as interference diffraction experiment, it display wave nature. If the experiment setup has a scale that is corresponding to the quantum nature of radiation, when light will display particle behavior such as in Compton scattering. De Broglie postulate. The postulate there should be a symmetry between matter and wave. The wave aspect of matter is related to its particle aspect in exactly the same quantitative manner that is the case for radiation. The total energy E and the momentum P of the entity for both matter and wave alike is related to the frequency of the wave associated with the motion by Planck's constant. We know that E is equal to h nu, where h is the Planck constant and nu is the frequency. But P is equal to h upon lambda, where P is momentum, h is the Planck constant and lambda is the wavelength. Derivation of expression for de Broglie wavelength. We know that energy of photon of frequency nu or wavelength lambda is E is equal to h nu, but from mass energy equivalence or theory of relativity, energy of photon is E is equal to mc square. So h nu is equal to mc square or m is equal to h nu upon c square, where m is the mass of electron, h is the Planck constant, nu is equal to frequency and c is equal to velocity of light. So mc square is equal to h nu, but we know that nu is equal to c upon lambda. Putting this value in equation, we get mc square is equal to sc upon lambda. Therefore, momentum of photon, that is mc, is equal to h upon lambda. According to de Broglie, a moving material particle having mass m and velocity u exhibit dual character. Thus, mu is equal to h upon lambda. Lambda is equal to h upon mu is equal to h upon p. This equation is called as de Broglie equation, where h is the Planck constant and lambda is the wavelength of particle. A particle has a wavelength. Lambda is equal to h upon p. Is the de Broglie relation predicting that the wavelength of a matter, wave lambda, associated with the motion of a material particle with momentum p. Particle with linear momentum p. A particle with momentum p in pictured as a wave, where matter wave with de Broglie wavelength, where lambda is equal to h upon p. One numerical for that. A particle having wavelength 6.6 into 10 raised to power minus 6 meter is moving with the velocity 10 raised to power 4 meter per second. Find the mass of the particle. We have to calculate mass of the particle in these numericals. Given lambda is equal to 6.6 into 10 raised to power minus 6 meter, u, that is velocity of particle, is equal to 10 raised to power 4 meter per second. We know the value of Planck constant, that is h is equal to 6.626 into 10 raised to power minus 34 joule second. We have to calculate mass of the particle. We know the de Broglie equation, that is lambda is equal to h upon p, where h is the Planck constant and P is the momentum. But we know that momentum is equal to mass into velocity, that is m into u. Then de Broglie equation become lambda is equal to h upon mu, means m is equal to h upon lambda u, where h is the Planck constant, lambda is the wavelength, and u is the velocity of particle. We know all the value, that is h, lambda and u. Putting this value in equation, we get mass of particle, that is equal to the 1.004 into 10 raised to power minus 32 kilogram. Thank you.